Hey everyone, so today we're going to talk about some properties of integrals. It's a pretty low-key day, some definitions, but that's about it. Okay, an equation for the tangent to the graph of y equals arcsine of x over 2 at the origin is. So pause the video and find that. So we have our 0, 0, right? To find our slope, we need the derivative. So y prime equals... So now, one way to think about x over 2, that's 1/2 x. Sometimes it's easier to think of it like that when you're doing arcsine. Right. So the derivative of arcsine is 1 over the square root, 1 minus 1/2 x squared, and then times the derivative of the inside. So times the derivative of 1/2 x, which is 1/2. So then we plug in 0, so I get y prime of 0, 1/2 over the square root of 1, so 1/2. So I got y equals 1/2 x, which is not an option. So let's multiply both sides by 2, so 2y equals x. So that one is going to be A, so the answer is A. Okay, so some important properties. If you are adding two functions together, you can break it up to make it easier into multiple fractions. And the same is true with subtraction, right? It's really plus or minus. If there's a constant multiplying your function, you can pull it on the outside, just so you can avoid taking the antiderivative of it to make life easier. And then you can also, this one is A to B, and then you can break that into A to C and then C to B, as long as C is in the interval. So think of it like if you're finding the area under the curve, if it's easier, you can do this area and then this area and add the two together, as long as C is between them. All right, average value. Put this in your list of things to memorize. Be careful not to confuse this with average rate of change. The average value of something is 1 over b minus a times the integral of a to b f of x dx versus average rate of change, which is your f of b minus f of a over b minus a. So these are different, but notice they both have that b over a. They are very similar, but the answers are different, right? So average value versus average rate of change. Okay, find the antiderivative of these. So what this was saying was you could break this up if you want. You don't have to. I wouldn't do it here because it's silly. dx. So we can do this since there's two functions being added together. Not that it makes a big difference. Sometimes it's helpful. You'll see some problems later on where it's actually helpful. So antiderivative x cubed over 3 plus e to the x from 0 to 1. So that's 1/3 plus e minus 0 plus 1. So let's see, I get 1/3, so e minus 2/3 is my final answer. All right, how about 2? Pause and try it. So again, that whole idea of bringing a number on the outside, what we can do is bring that 3 out because it's a constant, 1 to e, 1 over x dx. And that's helpful because a lot of us know whose derivative is 1 over x, the antiderivative of 1 over x is easier sometimes than 3 over x, because what we get is 3 times the ln of x from 1 to e. So 3 times ln of e. Ln of e is 1, so 3 minus 3 times 0, right? Ln of 1 is 0, so we get 3 as our final answer. Right? Ln of e is 1. Ln of 1 is 0. Those are things you should know. All right, now this next one's a little tricky. It has come up before, though. So what do we think we should do here? Now, you cannot notice the properties we talked about. There was none about dividing or multiplying. That does not work. So for this one, what we have to do is simplify. So I'm going to rewrite this. I'm going to divide everything by 2x. So we get 3 over 2x squared minus 3x minus 5 over 2 plus 2 times 1 over x dx. All right. So that I divided everything by the 2x and simplified. So now I can actually find my antiderivative correctly. So let's see, I get 3 over 2x squared, that's x cubed, and when I divide by the 3's cancel. So 1/2 x cubed minus 3x squared over 2 minus 5 over 2x plus 2 ln of x. From 1 to 2. Well, this is going to be annoying to plug in, but we can do it. All right, so I have 1/2 times 8 minus 3 over 2 times 4 minus 5 over 2 times 2 plus 2 ln of 2 minus, now I'm plugging in 1/2 minus 3 over 2 minus 5 over 2, and then ln of 0 is 0. Oof, running out of space here. All right, I'm going to go above now. So we got 1/2 of 8 is 4 minus 2 times 3 is 6 minus 5 plus 2 ln of 2 minus, I can do all that inside. They all have a denominator of 2. So that's negative 7 over 2. So plus 7 over 2. All right, so let's see. That's 4 minus 11, negative 7. So this whole thing's negative 7. So we get 2 ln of 2 minus 3.5. And that's the final answer. Well, that was gross, but doable. It's more just tedious. It's not that it was hard. Okay. Find the area under the curve from 0 to 15. What do you think? So because it's a piecewise function, we're going to have to break it up. So we have got our 0 to what? 0 to 10 of that top one, because this only goes to 10, dx, plus, and then 10 to how much? 15. 100 dx. So we're breaking that up based on the piecewise function. So x cubed over 3 from 0 to 10, 100x from 10 to 15, and we're going to add those together. So that's 3,000 over 3. Let's see. 1500 minus 100. So 1,000 over 3 plus 500. That's 1,500 over 3. 2,500 over 3 is the answer. Making that common denominator, getting that answer. Not very hard. Pretty straightforward. Okay, now this one. A little harder. So pause, try it on your own. So we're integrating from -1 to 0 e to the x. And then 0 to 4 of x plus 2. Now, notice, what about this 2? What about that? So, if we think about the graph of this, -1 to 0 is something like this, right? And then at 2, so it's kind of like this. But that hole is so tiny, it's inconsequential. Like, you don't have to worry about it. I wouldn't worry about it because it's so small. Like, you're still finding the area below it, even though it's not included. It doesn't have an area that it's so small. So e to the x from -1 to 0, and then x squared over 2 plus 2x from 0 to 4. So let's see, we get 1 minus e to the -1. Let's see, 16. So that's 8 plus 8, so 16, and then minus 0. So we got 17 minus e to the -1 is the final answer. Now, if you want, you could sit there and just like figure out the area under the curve. If you didn't want to find the antiderivative of x plus 2, you could be like, okay, well, this is 4. The height here is 6. The height here is 2. And use like the trapezoid formula. So 1/2 times 4 times 2 plus 6. And you would have gotten 16. So you can do it that way if you want. I think it's harder, more work, but. Okay, so now here are the kind of the purpose of this lesson, where they give you information about the area under the curve under different sections, and then they ask you to find stuff. So what I usually will do, because for each of these, is I like to make a little number line for myself. It just helps my brain work. So I'm going for 1 to 2, and the area is -4 for f. So this is f of x. And then I'm going from 1 to 5. So I kind of make it right on top of itself. 1 to 5 of f of x. And that whole thing is 6. And then we have 1 to 5 of g of x. So I kind of like to write it out like that. But this is a different function. So based on that, go through, pause the video, see if you can figure these out. So the area from 2 to 2, anything, the area under the curve where it's not a change is just 0. Okay, so this is 5 to 1, so it's reversed. So what do we get instead when we, instead of 1 to 5, it's 5 to 1. So what's the answer there? -6. You just negate your answer. So this is your 3 times 1 to 2. 1 to 2 is -4. So 3 times -4 is -12. All right, 2 to 5. How are we going to do 2 to 5? Well, 1 to 2 is -4. So if we break this up into 1 to 5, f of x minus 1 to 2, f of x, that equals, we're taking off and getting that 2 to 5. I can write. This makes sense. So we're taking the 1 to 5, right, this whole guy, and we're taking off the 1 to 2, and that leaves us with our 2 to 5. So 1 to 5 was 6. 1 to 2 is -4. So we end up with 10. Right? So that's that process. It's really common. 1 to 5, f minus g. So let's see. 1 to 5 of f was 6, minus 1 to 5 of g was 8, -2. And then very similar, so this time we have 4 times 6, minus 3 times 8. So that's 24 minus 24, which is 0. That's it. I like these. I think they're fun. All right, last one. Try it on your own. All right, so we have 1 to 9 is -1, and then 9 to 7, or 7 to 9 right here is 5. And then we have an h. Okay, so 1 to 9, -2 times f of x. So that's 2. 1 to 7, so we need to figure out the 1 to 7. So 1 to 7 would be 1 to 9 minus 7 to 9. Right, 1 to 9 minus 7 to 9 gives us our 1 to 7. So 1 to 9 was -1 minus 5 gives us -6, and then times the 6 they gave us. So the answer is -36. I feel like these numbers don't always make sense. I just do the best I can with it. Okay, so this one's flipped. All right, so if we flip it, we need to throw a negative out front. So f minus g. So negative, what's f from 7 to 9? That's a 5. And then g is 4. So we get -1. And then 7 to 9, 2. F was 5. G. Oh, I forgot to change it to H. Whatever. This is G. Just kidding. 4. 20, 30. That's it. All right, so we will be doing this in class, so take a picture of page 425. Make sure you include everything. The 7 to 16, 25 to 31, it might go on to the next page. All right, have a great day.